Alright guys, I'm going to be touching indices. I know you guys are waiting for it. Alright, indices. Then after the rows we can enter indicial equation. Come on, man. Alright, let's start from the laws of indices. Show my ribbon.
Sure, you are done with the set.
Yeah, we are done with the set. Yeah, it's uploaded to Google. So now laws of indices. I'm going to break the law. I'm going to break it. The multiplication law, the division, the fractional index, the zero index, the negative index, the blah blah blah, and the blah. Alright. So we have. Let's start with the first one. We have. Let's suppose we have a raised to power n multiplied by e raised to power n. Then you can see we're having the same base. For instance, multiplicative law. When you're having the same base, different power, what do? Multiplication will become addition, but it will only affect the powers. This multiplication will become addition, it will only affect the powers. So since we're having same base, just pick one of these base. Then it means that you're having a raised to power what? M plus n. This one has turned to plus, so it's affecting only power. Okay. So now, if you have this, the number one law, multiplication law. So if you have something like this, a raised to power m divided by a raised to power n. So this one is division law. So this division will change to minus. So we assume that the opposite of division under the law of indices is minus. So it's going to only affect the power. So you take one of the base, which is a, then we have raised power n minus n. So if you have the power law now, a raised power m, we have n outside. So to expand the power, it becomes a raised power m n. So negative index, okay. So if you are having, for instance, you are having a raised to power minus 1, it's the same thing as 1 over a. If you are having a raised to power minus 2, the same thing as 1 over a raised to power 2. If you are having a raised to power minus 3, it's the same thing as 1 over a raised to power 3. You can see that the negative is just removing here. If you have something like, for instance, a raised to power minus 4, it's the same thing as 1 over a raised to power 4. You have something like y raised to power minus 6, it's the same thing as 1 over y raised to power 6. So you can think of any of that in yourself. So I don't want to limit it to this side, that's why I expanded it. Alright, so if you're having, let's say you have x, square root of x. You know, this one normally means, this square root means when something is carrying raised power half. If you have square root of x, it's the same thing as x raised to power half, because this square root means raised to power half. If I have for instance square root of y, how will I write it? I'll write y raised to power what? Half. If I have square root of z, it means z raised to power what? Half. Now let us suppose that we now started putting number behind all this root. Let's say I have something like, I put 3 at the back like this, cube root of x. But if you don't put anything there, it's going to be raised to power half. But once you start putting something there, maybe for instance you put 3 here, so it's going to be x raised to power 1 over the number you have put here, 1 over 3. If I put another value there, maybe I put x here, that's equals to this 5 here. That will be x raised to power 1 over 5. You can think, if I put 27 here, I have 1 over x raised to power 1 over 27 and many more. What if I put negative here? Let me suppose I put negative here. Okay, let's assume that we have 3 here, but I now put negative here. So this one is going to be x raised to power minus 1 over 3 because of the negative that is here. What if I put 4 here? X raised to power minus 1 over 4, which is also the same thing as 1 over x raised to power 4. You understand? If I put 3 here, I'm just trying to test one so you can get it. This will be x raised to power minus 1 over 3. Write your power like power, don't let it come down to 1. Because if you write, as for me, if you are writing power in front of it, as me you want to write x raised to power minus 1 over 3, you now write it like this. I won't be able to differentiate between power and base. I will call you 0. If you are writing your power, please let it be at the position of power, please. So because of your lecturer, don't write rubbish. God bless you. Alright, so I'm moving on to some typical example. Before then, let me end it up with this. Zero index. Any raised to power 0 is 1. 99 raised to power 0 is what? 1. X, y, everything is power 0 is what? 1. Anyway, so lastly, suppose you're having cube root. Okay, let me just put it like this. S A then B. If you're having something like this, how do you express it in index form? It becomes x raised power a over b. Soft. X raised power a over b. Imagine I'm having something like this. 4. I'm having y. I'm having 5 there. In index form, how do you express it? That will be y raised power 5 over 4. This one will be the denominator. And the numerator, this one will be the denominator of the power. If I have something like this, in call 27 and 7 and 50. So how do you express it in index form? I will 7 raised to power 50 over 27. No stress. So all these things, all these little things, just know it. So before I start anything, all these should go and learn it. Before I start anything, I'll just start with some freestyles. So imagine I have something like 8. You have to know the index of numbers. A lot of numbers. So what's the index of 8? Index of 8 is 2 raised to power 3. 2 times 2, 2 times 2 times 2 is 8. Alright. What's the index of 9? The index of 9 is 3 raised to power 2. That's 9 times, index of 9 is 3 raised to power 2. Understand? Like 2 multiplied by 2. So it's going to give you this. So what if I have 125? Index of 125 is 5 raised to power 3. There are some numbers you can't find their index, but there are some numbers that you can find their index. You can just keep trying until you get index of. And there are some numbers that have different index. For instance, 16. You can decide to use 4 raised to power 2 for 16, depending on what you are solving from. And you can also use 2 raised to power 4. So a lot of numbers with their different index. Okay. So now I'm going to be solving a question so you can understand. But before I solve that question, let me just give you some basic questions applying this rule. So what's example 1.0? Simplify the following. So question 1. So I have 3 raised to power 2 multiplied by 3 raised to power minus 1 multiplied by 3 raised to power 0. Then 2. I have cube root of 27 2. Okay, 3 sorry. Times 3 raised to power minus 2. So let's solve this problem, okay? So solution. Let me divided by 3 raised to power 1. So solution, let's solve the first one. So this one is this base is common, right? So pick one of it. I have pick one. So anyway, these times you need this we change to plus. It really affect the power. How does it affect the power? Then the power become 2 plus into bracket minus 1 plus 0. Okay. So that's 3 raised to power. Remember that plus times plus is plus, minus times minus is plus. Like charges repel. Plus and plus is plus, minus and minus is plus times minus is plus, minus times plus is plus. Àwọn ètò different plus tó máa fún wa. Àwọn tó different minus tó máa fún wa. Àwọn tó different minus tó máa fún wa. Àwọn tó the same plus tó máa fún wa. So the similar ones will give us positive, while the similar one will give us negative. So that's it. So now 2 plus times minus is minus. Then you do your plus and minus 0. What am I doing? Minus 1 plus 0. I'm trying to listen up. It's late already. So we're having 3 raised to power 2 minus 1 is what? 1. 1 plus 0 is 1. So 3 raised to power 1 is 3. Alright. So that's it. So number 2, we have cube root of 27. Everything raised to power minus 2 times 3 raised to power minus 2 divided by 3 raised to power 1. How do you solve this problem? It's very easy. So change this one inside the bracket to index. I first deal with the bracket, don't stress yourself. So what do you have inside the bracket? If you change this one inside the bracket to index, I taught you in the beginning of this video. This one to index form, how do you write it? So you write it as 27 raised to power 1 over 3 to index form. I explained in the beginning of this video. If you don't get it, rewind this video back. So what's the index of this one? So far you can find the index, find it. Except if it's not possible for you to find the index, you leave it like that. But look at it very well, think rationally and critically of whether you can find this index. So what's the index of this? The index of 27 is 3 raised to power 3. You can see. So then you bring this one back. Since this power of this index, this is it. this is the 27. Since it's having a power, so you put power in front of power, okay? So power can cancel power. So we are left with what? 3. So this one here is what? Okay, let us solve it accordingly. 27 is power 1 over 3. This is power minus 2. Okay? Times 3 raised to power what? Minus 2 divided by what? 3 raised to power 1. So this one is same as 3 raised to power what? 3 over 3. Abi? Let me do like this. The index of 27 is 3 raised to power 3. Abi? Multiplied by this is also power. Put power in front of power. Okay? Then minus 2 times 3 raised to power minus 2. Okay? Divided by 3 raised to power 1. So 3 take care of 3. We are left with 3 raised to power 1 minus 2 times 3 raised to power minus 2 divided by 3 raised to power 1. So this one is the same as power law. This power inside multiplied the power outside. So 1 times minus is minus 2 times this one is having minus 2 divided by what? 3 raised to power 1. So let us continue from this one. So pick one of this base. You have 3. So minus 2 times you change to plus. What are we having here? Minus 2. Okay. Division change to minus. Then what do you have here? 1. So this one become minus 2 plus and minus is minus. 2 minus 1. This is 1 minus 2 minus 6 minus 4 minus 4 minus 1 minus 5. So it's either you leave the answer like this, or 1 over 3 is power 5, or 1 over 3 is power 1 over 32. Anyone is fine. So it's very easy. If you are following me, you will understand. You don't have that time. You don't have that time. If you answer like this or you leave your answer like this, sorry, I explained the error there, okay? What you are stressing. It's not easy. What's it being that cannot subscribe? What's it being that? And what video you cannot understand? Cannot subscribe. Oh yeah, for like me. What is the?
So you have class tomorrow?
I have class tomorrow. MTS. Solve each of the following. Let's show. Solve each of the following. A is 0.25 raised power 2x plus 1. 10 raised to power minus 4 equals to 10 raised to power minus x equals to 0.00001. C is 0.25 raised power 2x plus 1 equals to 64. D 10 raised to power minus x equals to 0.00001. So sorry about solution. This one is very easy. Let's start with the first one. It's 0.25 raised to power 2x plus 1. So you can convert this one. You have to convert it to decimal. The fraction. That's 25 over 100. Okay. All raised to power 2x plus 1. 25 here 1, 25 here 4. That's 1 over 4. Okay. Raised to power 2x plus 1. Okay. I think it's equals to something. I'm using for a question today. You don't share me to your long. So 64 and then so everything equals to 64. 64. Alright. So at this junction, this one is the same thing as you can change this one to an index. That's 2 raised to. Do you agree with me? If you agree with me, it's the same thing. 2 raised to power minus 2 is the same thing because this one can give me back 1 over 2 raised to power 2. 2 raised to power 2 is 4. So obviously it's the same thing. 2x plus 1. 2x plus 1 equals to 64. So this one 2 raised to power. This one can expand this one. That's minus 4x minus 2 equals to 64. 2 raised to power minus 4x minus 2 equals to 2 raised to power 6. Okay, this one cancels this one. Minus 4x minus 2 equals to 6. CLT. That's minus 4x equals to 6 plus 2. Minus 4x equals to 8. S equals to minus 2. That's our answer. Okay. So for the next one, this is a night class. Night class. 0.00001. So this one is 10 raised to the power minus x. This one is same thing as 1 times 10 raised to the power 1, 2, 3, 4, 5. Okay, this one is 10 to the power minus x equals to 10 raised to the power minus 5. Okay, so minus x. This one is this. Understand? It's very simple. So the next one, actually tell it. So I don't know why it's repeating itself. I've done this one already, so that's all. That's the question. Wait, make I run this last one. So make I solve it. Now only one question I will solve. I have one more as assignment. Máa fi ilé question one, máa fi question two yẹn ṣe ìkejì. Question two was now this one is already converted, so you cannot find any index anymore. 3 raised to the power 3 plus this. Anyway, alright, now this one is the same thing as 3 raised to the power 2x times 3 raised to the power 1. Do you agree? Same thing. If you are applying this, you take one of the base, then you get this one back. You say 2x plus 1. So I separated it back to the original question. So minus 18 into 3 raised to the power x minus 81 equals to 0. So this one we can do it in form of 3 raised to the power x, then 3 is outside, times 3 raised to the power 1 minus 18 into 3x minus 81 equals to 0. Do you agree with me? It's very simple. So let 3 raised to the power x equals to p. That will be p squared into 3 raised to the power 1 minus 18p minus 81 equals to 0. So this is the same as 3p squared minus 18p minus 81 equals to 0. So because of time, at the end of the day, if you factorize it, okay, you can still reduce this one. So when we reduce this, we are having p squared minus 6p minus 27 equals to 0. So factorize completely. You can do that yourself. There's no time. Sorry, it's late. I can't break it. So this is p equals to minus 3 or 9. Minus 3 or 9. Minus 3 or 9. So now recall that 3 raised to the power x equals to p. So when p equals to minus 3, that is by x equals to minus 3. Okay. So on the line. So when p equals to 9, so 3 raised to the power x equals to 9, which implies that 3 raised to the power x equals to 3 raised to the power 2. This one cancels this one. Then which implies that x equals to 2. We are concerned about this. So the rest is nothing to write on about. So now I'm going to be cleaning this one. I think it's understandable, no stress. So I'm going to do the last question. This one is somehow crazy. I've dropped the video before now. That was the first video. Go back to the first video, but I want to repeat it. Alright. I have the question here. Screenshot comment. More person not coming. Here's the question. One in go and they come. How far about the next video? So let us solve for C in 2 raised to the power 2 equals to 2 raised to the power 30. Okay, last video that much really had them post here. I'm tired. Alright, so this is an exponential tricky equation. So now look at this. We find a way that this t gets here, like, and numbers go here, t comes this side. Either otherwise is okay. So what you do is that t root both sides. That will be t raised power t equals to t raised power. So is t root. The t root both sides. This one take care of this, and you are left with 2 raised power 1 equals to what? 2 raised power 32, all raised power 1 over 3. That's interpretation. So again, when you get here, you 32 roots both sides. So that will be 2 raised power 1 over 32 equals to 2 raised power 32 over 3. You know this one now. Then we have 32 root both sides. This one take care of this one. So it remains what? 2 raised power 1 times 1 over 32. Okay? Equals to 2 raised power 1 over 3. No space. So since we are having 2 here, then this one becomes 2 divided by 2 because it will give us this one back. If it is still 2 divided by 3, but since it's 2 divided by 2. That's the principle. Okay? I 2 raised power 2 divided by 2 times 1 over 32 equals to 2 raised power 1 over 3. Okay, so this is 2 raised power 2 over 64. Okay, no stress, equals to 2 raised power 1 over 3. So 2 raised power 2 times 1 over 64, right? Equals to 2 raised power 1 over 3. This one is 4, right? This one becomes 4 raised power 1. Okay, so we are still going. So equals to 2 raised power 1 over 3. So this is 2 divided by 2. Okay, 1 over 64 equals to 2 raised power 1 over 3. So this is the same thing as 16, right? 16 raised power 2 over 128. Do you agree with me? Equals to 2 raised power 1 over 3. 16 raised to power 2, 16, right? Let's see how it goes. 6 times 6 is 36. This is 6, 9, 1, 6, 5, 1, 256. So this is 256 like this. So now this thing is power 2 times 1 over 4 is equal. Just let them continue the rest of me. I'm tired. So at the end of it, 256. So at the end of the day, you should be having 16 raised to power 2, then 1 over 256 at the end of the day. So your T will be equals to 256 and your T will be equals to 256. So in our next video, I'm going to draw 5 calculations on this. Sorry, it's nice class, so just bear with us. I'm tired, I'm exhausted. So in our next video, I'll draw 5 questions on this. I'm going to solve it so you can get it. This is an explanation. I'll go to my previous video. I'll draw something related to this. Go and check it deep down. Thank you very much.